Hello, my name is Frank Raffaelli, and I wrote this 2D convolution tool using a LabVIEW, which is an authorware program. And I did it mostly because I was getting frustrated with some of the limitations in GIMP. Although it's very useful as a edge detection tool, I was having some difficulty sizing the masks and getting the masks to work properly and render a differentiated image. So the way it works is LabVIEW is it's an authorware package. It has some background functionality, graphing. It gives you the ability to manipulate numbers, use arrays, and so forth. But it also has embedded within it a function called MathScript, which allows you to customize your own functions using a syntax that's very similar to MATLAB. And if you already know MATLAB, it's handy. This is an example of the code that I used to generate a Gaussian mask for a 2D Gaussian filter. And you can input a standard deviation and the size of the mask, and it outputs the mask itself. And this is the heart of the program, the 2D convolution. This is the source code, also in MathScript, and it uses leverages the MATLAB command conv2d. That really makes things simple because you can name this parameter called same, and you don't have to deal with adding zeros to the image edge. This is how to get it. Link to the executable is up top, and this doesn't require installation of LabVIEW. What it does is it will put the runtime engine on your computer, and then the executable can run, but it doesn't need LabVIEW. If you want to make changes, then you will need to download LabVIEW, and you can get it for free. The student version has all the functionality within this software, and you can get it at the link shown here. Next, there'll be some videos on pre-installation and installation and then operation of the system.
Okay, welcome to the installation guide for the 2D Convolver. It's a pretty large zip file, so I sent the link in the Canvas system, and the link is here. Go to the link. You should be able to download everything. So you're going to get a warning because the file is too large, so click download anyway. Let the download proceed. And so once the download is finished, you can navigate to the file location, and then go ahead and I'm just going to extract the files to a location on my desktop.
Welcome to the installation guide. This video will walk you through the steps required to install the 2D Convolver. Once the zip file is in some folder, then double click on Setup, and it should bring up a dialog as long as you click yes, and go ahead and accept the defaults, the license agreement, and I'll come back when it's closer to installation. The installation takes about 3 or 4 minutes. Okay, go ahead and click Next, and it may require you to restart your computer. After you do that, then I'll show you the next step. Okay, once you have restarted your system, go ahead and find 2D Convolve _v01. Put it in my shortcuts list here. If it's not there, just search for the name and open it, and it should come up just like you see it here. I'm going to demonstrate a couple of things, but first, just to show the controls, you would open your image file here. Your mask appears down here in this area, and the images that are being processed, the input image is here and the output image is on the right. So now we're ready to resume the demo. I'll open 2D Convolve, bring up first import an image, and this defaults to the directory that the application's installed in. And I'll just open this image, which is let's see, here we go. So this image has already been edge detected with Sobel in GIMP. And what I'd like to do now is go ahead. This comes up in auto update mode, which means all I need to do is drag the cursor around and it will sample a section of the image, and I can change the size of the mask here. So for example, if I only need an 11 by 11 mask, and this is a good feature to zoom in on here because it has a lot of information and it's fairly unique. So what it will do is it'll convolve that shape with the image, and I'm going to go ahead and show you the 3D graph of the convolution mask, and it looks like the shape. Now we won't get a very interesting result if we just hit convolve, because there's all positive features in here, and as Professor C noted, we would need some negative features around, so we can adjust that by changing the contrast and the brightness with these controls here and keeping an eye on the total sum. We'd like that to be a positive value between say 10 and 500, and right there is close enough, but I'm going to drop the contrast down a little bit so that I can make the largest value a little bit lower. Alright, so that should do. Now we'll go ahead and hit convolve, and it should resolve the feature of interest. Okay, so you see the feature that we wanted is lit up quite a bit, and we can adjust that even more by adjusting the export contrast. We can increase the contrast so that only the features of interest will show. Now these other features here, these bright features here, also show up in the convolution mask. We can go back to the array. So the process is either manual or automatic. When it's on manual, you can right click, you can zero the array, and we can also read from a CMT file. We'll do that demo next. So as we just saw, we can customize the mask using a sample of the image, and let's import a new image. This one, and the baby playing with blocks image has a heart on the t-shirt. We'd like to see if we can look at that. We can also invert the image if we want. If it's not already monochrome, we can convert it to monochrome. For this example, I'm going to load into the array. I'm going to read from a CMT file or a convolution mask template file. And this is a Gaussian 11 by 11. And if we look at it in the 3D graph, indeed, it looks a little bit like a, I'm going to go to full screen. It looks a little bit like a Gaussian mask. We can turn this on and see it from a couple different angles. So let's check to verify now that the Gaussian mask will do what we expect it to do. There's the Gaussian mask in the array and the 3D graph. We can convolve that with the existing image. We should see a blurring effect, which is what we will see. So the next step is we can try manually editing the mask file, and as we saw, it's a Gaussian, but we can change that by cheating. You can put a negative in front of the signs of the 4 center elements in the array. Now let's check out, that's brought the array sum down considerably. Now let's see what that looks like in the 3D graph. A little bit like the sombrero. We missed a point here. Let's go back. Minus 212. There we go. A little bit like the Laplacian of Gaussians. Not quite, because we did it manually and crudely, but let's see what happens when we convolve that with the image. And it looks like we do indeed get a little bit of an edge detection effect. It's inverted, so we can invert this image and we can see the outlines here pretty well. And of course we can always adjust the export contrast to highlight those shapes again. As we scan around here with a 15 by 15 shape, we see we can isolate the heart shape and other shapes in the picture. Although this may not convolve well, we'll give it a try. Turn the brightness down, the contrast up, dial it up to 11. Double check what the 3D graph looks like. Yeah, it kind of looks like a heart shape. And then let's do the convolution. Oh, it still lit up the heart. So let's reduce the contrast and see if it's still there. Yeah, it seems to be the only shape that got highlighted in that case. So that concludes the demo for this tool. If you have any questions, I'll send out email my email in the link. And thanks for watching.